Hello and welcome to the video on multiplication methods. We will start by reviewing the right to left method, the one you know, the one you're used to. And what we're going to do is we're going to say 45 times 3 from whatever word problem it may come from. The first thing, so 45, let's say here, times 3 is our question. The first thing we do in the classic method is write the first number and then line it up with the second, which we'll keep small in this basic situation. Then right to left, we're working right to left, so we do the ones first. 3 times 5 is 15, and the version you might be familiar with has as you write the 1 over there. Then you say 3 times 4 plus the 1. So 3 times 4 is 12, plus 1 is 13, and that is, of course, your answer. Another more detailed version, which is perhaps an easier one to introduce to students or learn for the first time, is one where I don't do this carry over effect, or what looks like carrying over, because it might confuse me or someone, and I don't remember, do I multiply, do I add this, what do I do with these two numbers? To avoid that, we could say 3 times 5 is 15, and I'll write the 15. Then we're going to multiply the 3 with the 4, which is going to put me in the tens column, so I know that will be a 0. 3 times 4 tens will be 12 tens, or 120, and I end by adding the two pieces together to, of course, get the same answer. Now, whichever version you're using, the question is, how does this help me transition to an efficient mental calculation if I don't have a piece of paper handy? Does the method encourage me to let that go and do this in my head? Well, to see how it does not, if I have a much larger number, like 2,431, for example, and let's say I want to multiply that by 3 again, the right to left method has to wait for all the numbers. Even if I know I'm multiplying by 3, I have to wait to hear the entire original first number before I can start multiplying, because the method requires me to multiply right to left. So I have to wait, and I have to remember all these digits. Now I can say, okay, 3 times 1, I'm doing everything backwards. 3 times 1 is 3. I can't say this 3 because I say numbers left to right. Yet this method is constructing the answer right to left. And then I can say 3 times 3 is 9. I have to do this all in my head. 3 times 4 is 12. Maybe if I do the short version, I still have to remember the 3, the 9, the 2, because I can't say anything, because I need my left digit to start saying my number. And then finally 3 times 2 is 6, plus 1 is 7, and I can say, oh, it's 7,293. But who would be able to do this in their head? There are too many digits, too many things to keep track of, because you have to do everything before you can say anything. A right to left method is completely inefficient. Instead, why don't we use a method that works with us as we say, as we hear a number? A left to right method might be much, much more straightforward in helping me graduate to a mental calculation. We'll again take the 45 times 3, but the good news is that there isn't much difference in what I do. I can still set it up in exactly the same way. I simply start with the tens column instead of the ones, and say 3 times 4 is 12. Well, it's 3 times 4 tens, so it's 12 tens, or 120. the writing of the 0 there is optional as long as I line everything up. And then I can move on and say, oh, the next thing I have to do is 3 times 5, and that's clearly 15. And then I can add them up, 135. So there's very little adjustment to do when it comes to switching or converting to a right-to-left method. It's pretty much the same. I do have the option to help myself even a little more. But before we do that, let's keep in mind here, how is this now helping me? And how is it not exactly the same as what we did up here? It looks the same. And on paper, it certainly is essentially the same in terms of effort required or how much you write down. But now, if this 45 was a bigger number, let's suppose, I can't remember the other one, we'll just make it up, 1,273, and I'm multiplying by, not 9, by 3. If I go left to right, and I know I'm multiplying by this 3, as I'm hearing the number, oh, what you're multiplying by 3 is 1,000, and I already know my answer is going to start with a 3,000. I can do this multiplication that I'm now just laying out here in detail for us to keep track of, because we have paper available. I can do the multiplication as I'm hearing the number. Then I hear 200 right away. I know I'm building my answer as I'm hearing the number. 70, well, no, 3 times 7 is 21. So yes, there's some updating required. My line was a little faster. And 9. But this method, even though it seems like a lot more writing down at this stage on paper, this helps me transition much better to a mental calculation. To see that a little bit more, I can take my 45 and I can write it all as a multiplication sentence, if you will. And just update this quantity that I have according to the instructions that are given. If I just intuitively understand what multiplication requires me to do and how I need to update to get my end result, this 3 shouldn't really be seen at an intuitive level as a ones number, simply as an instruction. It's not the same as this 5 is. So I have 45 things and I need to triple it. I can do that in steps. I can do that by first addressing the 40, and 3 times 4 will be 12. Now, I need to update this to, so my lines are not horizontal in any way here. Let me see if that's better. There we go. I can update this because I'm in the tens column. I can use a 0 to help me keep everything in line. 12 tens is really 120. So it's more of an updating procedure, and I've taken care of tripling the 4. Next, I have to draw a straight line. I have to still address the 5 that I have to triple. I have my 120 something that I'm waiting for. I still have to do this multiplication. So as I'm hearing 40, I have my 120. It's ready. I can say it even. I can say 100, and now I still have to wait for the other one. The 5 multiplied by 3 is 15. But it's not quite fitting into that position. So I finally updated to 135. What might seem a little clunky now and a little confusing is simply another version of this left to right method that works with me as I'm performing a mental multiplication. As I'm hearing the number, I'm simply updating Oh, multiplying by 3. Okay, so what's my number? 40. I immediately know 120. 120. It's not necessarily set because this guy could update with a little, with depending on what my other number is. And now I see, oh, it's a 5. Oh, 135 instead of 120. But I can start to say the number as I am performing the calculation, the multiplication, and it becomes much more efficient when I have to do these things in my head. For more, you can watch demonstrations of a left to right multiplication on 3 levels. First level is base blocks, then a written method again, just like these, but left to right, and lastly, a mental multiplication completely without writing anything down.